Hello everybody, this is Jim Corkins, and we are continuing on with vectors, and we are in 2.2 unit vector notation. Again, if you haven't done the reading, please do so now. Okay, unit vector notation is about taking units where we were solving in those tutorials where there were 3 boxes to the right and then 2 boxes up. Well, 3 boxes to the right would be positive 3, positive 3 I hat, and 2 boxes up would be 2 j hat. Okay, so unit vector notation takes the magnitude of those vectors, and then it adds the magnitude of those vectors to a direct. It gives those vectors a direction as I, j, and k, which is x, y, and z respectively. Okay? So the unit vectors have magnitudes. They don't have units to them. So if you walked 3 meters to the right, that would be positive 3 I hat. Okay? So it removes the units, and it actually makes the mathematics a lot easier. So it's a tool used to make the mathematics easier. Okay? And later on, if you get into when you get into matrices, that's where it's really important to use unit vectors. Okay, so we are going to learn about unit vectors. Okay, now if you have to add unit vectors together, okay, so suppose you had a vector A, which is its x component would be I hat. It would be A I hat, A j hat, A z, A k hat. And vector B, which would be B I, B j, and B k. Adding the vector components together, you have to add them by their unit vectors. So you would take the x direction of A and add it to the x direction of B, and that would be the overall unit vector in that direction. You do the same thing for the y direction. AY plus BY would be the j hat, and then the overall resultant vector of in the z direction would be AZ plus BZ k hat. Okay, now we're not going to do a lot of 3-dimension vector stuff in our class. We're going to be doing more just 2 directions, like the I direction, the x direction for the I, and the y direction for the j. When you need to subtract these, like if you had to subtract A minus B, you would just go ahead and subtract those through. Okay? And subtract each one of those. So you would take, so A minus B would be AX minus BX, AY minus BY, AZ minus BZ, I, J, and K. If you have a scalar to those, like, so for example, if you had a scalar like 3 times A, you would multiply each one of its components by that 3. So if you had a vector 3A, this would be 3AX I hat, 3AY J hat, and 3AZ K hat. You just multiply each one of those components by the scalar. Okay? So let's go ahead and try this out. So let's just start really simple. Suppose you had a vector C, as indicated by here and by this coordinate system. Okay? What are the x and y components of vector C? With the x direction, comma, y direction. Okay? So find the length in the x direction, find the length in the y direction, and apply the directions. Okay? So try that now. Please pause the video. Okay. So, having my little pen. So in C is going to be pointed to the left, 1, 2, 3, 4. So C, the C component right here, this is -4. Okay, And the y component is going to be, well, 1, 2. So this is going to be 2. So positive 2. So since you have to put these together as x comma y, this is going to be negative 4 comma positive 2. So the answer we're looking for is D. All right. Now, using that, I want you to point out the same exact thing, but I want you to use unit vector notation. Okay. So what is C in unit vector notation? And please use your thinking for the last problem for this problem. Okay. Try this on your own. Pause the video now. Okay, so this is the same vector which is pointed to the 4. It's pointed in the negative 4 direction in the x direction, and in the y direction this is going to be positive 2, which is going to be j hat. So negative 4I plus 2j is C. So this B is going to be, choice B is going to be our vector C. Okay? So, pretty easy. Okay? Let's try this again, but now you don't have any run through. So, here is vector C as indicated by this coordinate system. Which one of these 5 choices matches vector C in this case? Try it on your own. Pause the video now. Okay. So vector C is pointed to the right three vectors, 3 boxes. So it's going to be a positive 3I hat. And it looks like it's pointed down 1, 2, 3, 4. So negative 4 j hat. So we're looking for positive 3I hat minus 4 j hat. Positive 3 negative 4. So B looks like the correct choice. All right. Let's try some vector addition. Okay. So we've done vector addition in 2 dimensions before in the tutorial I want to say this is 2.0. Okay. Now we're going to be using unit vectors. Okay, and there's a lot of ways to do these problems. You could add these 2 vectors together, find the resultant vector, and then do it that way. Or you could add and subtract components. Okay, so there's a lot of ways to do this problem, and I want you to do this whatever way you're most comfortable with. But for us, when we review this problem, when I'm done setting this up and you try it, we'll do it both ways. Okay, we'll do it by doing vector addition and then finding components of the resultant vector and just doing it purely mathematical. Okay. So try this one on your own. Which one of these 6 choices matches up with the vector addition of the red vector plus the blue vector? Please pause the video now. Okay, well, here we go. Let's do the resultant vector. And we need to start with something. So I'll start with the red vector. And I put this here as a work area in case I need it, but I don't think I need it. So what I'm going to do is this blue vector is pointing to the right 4 and down 4. So starting here, I'm going to add the blue vector to this. And it's going to go to the right 4, 1, 2, 3, 4, and it's going to go down 4, 1, 2, 3, 4. So this is the blue vector right here. Okay, which is right here. Now the resultant vector, again, goes from start to finish. So you started here, you walked up and to the left, you walked 3 up, you walked 1 to the left and 3 up, then you walked to the right 4 and down 4. So you ended right here. So the resultant vector, which is the black vector, is this one, which is 1, 2, 3, which is going to be positive 3 I hat, and then down 1, which is negative 1 j hat. Okay? Now, there's another way to do this. Okay? So the red vector, we could do this just by units. So C, or the black vector I'm going to call C. I'm going to call this A, and I'm going to call this B. Okay? So C is going to be the resultant. Now, before I get too far into this, we are going to be doing this right here. We're going to take the x direction components first and add those together, and the y direction components and add those together. And some of those are negative, so we're actually going to be subtracting, but anyways. So C, which I'm going to totally need more room, is going to be equal to, the AX component plus the BX component, I hat, plus, and this will be J hat, plus the BY component, AY component, plus the BY component. So there's a lot of ways to do this. I'm not sure which one's better, but we're going to take the AX component, which is -1, and then we're going to add the blue vector, which is +4. Okay, and I'm doing this step by step. I know it's taking forever, I'm sorry. The AY component is +3. The BY component is -4. And that is J. So the answer to this part of it, which is the same thing that we just did, is going to be 3I plus, that should be -1j. So both ways are equally valid. One's more mathy, the other one is vector addition, and then you just find out the components of that resultant vector. Okay, so it looks like this is the choice, the top one. All right, let's try another one. And so this is vector addition of a lot of different vectors. Okay. Okay, so given the two vectors, so given these two choices, 3I plus 2j and -2I minus 3j, which of the vectors on the graph is a result of the vector addition of these two? Okay, so this is teaching you the mathy version. Okay, so we're going to go C is going to be equal to 3I minus 2I, which is 1I, so +1I, and +2j minus 2 plus 2j minus 3j, and I don't know why that is bothering me. It's +ij, so +2 minus 3 is going to be -1j. So this is going to be, so we're looking for a vector that is pointing to the right 1 and down 1. So that is vector D. So the correct choice is D. Okay. Now, this next example is a problem where it says a rabbit is escaping a fox. It's running 40 degrees north of west at 10 meters per second. So this vector is a velocity vector, is pointing north of west, so up and to the left, west. I'll suppose I should draw this here. If this is positive x, positive y, negative x, and negative y, north, never eat sour watermelons. Okay, so this north of west vector is pointing up and to the left, as described by this green vector, and it's at 10 meters per second at an angle of 40 degrees. And so what they want you to do is they want you to write the rabbit's velocity in terms of its components and unit vectors. Okay, so go ahead and pause the video now and see how, and try this on your own. Okay. Okay, we're back. So just so you know, the answers are right here. But let's go ahead and try this on our own. Okay. So this vector is 10 meters per second, pointing up and to the left. So the x direction component vector is right here. The y direction component is right here. So this component, the hypotenuse, is 10 meters per second. And so just like our trigonometry review, we've got to take this and the angle and turn it into its two component vectors. Well, the x direction component vector is going to be hypotenuse cosine of 40 degrees. And that is pointing to the left. Okay? And that is I hat. So the x direction component vector, which is Vx, is negative 10 cosine 40 degrees I hat. Or in other words, that is going to be 40 degrees is 0.766. So this is going to be negative 7.66 I hat. Okay? And so I forgot the units, which is going to be meters per second. The y direction component unit is going to be positive 10 sine of 40 degrees j hat. So let's do the math here. 40 degrees and sine 0.6428, so times 10. So 6.43 is going to be 6.43. So this is going to be a positive 6.43 j hat in meters per second. So the overall velocity vector, which is Vx plus Vy, that's going to be equal to negative 7.66 I plus 6.43 J in meters per second. Okay. So pretty simple problem. Hopefully you've learned a lot about unit vectors. And again, if you haven't done the reading, please do so. I hope you had a great day. Have a great day.